In this video, we will see the comparison of AC and DC circuits. So first definition, AC means alternating current, which is an electric current whose magnitude and direction change periodically with time. The current continuously reverses its direction, usually in a sinusoidal form. Whereas DC, that means direct current, is an electric current that flows only in one direction. The magnitude of DC may remain constant or vary slightly, but the direction never changes. Second, waveform. The waveform of AC is generally sinusoidal, although square, triangular and other waveforms are also possible depending on the application. The waveform of DC is represented by a straight horizontal line because its voltage and current remain constant over the time. Third one is frequency. It is the number of cycles completed in 1 second and is measured in hertz. For AC, the standard frequency is 50 Hz in countries like India and 60 Hz in countries like USA. Since DC does not change direction, its frequency is 0 Hz. Fourth one, direction of current flow. In an AC circuit, the current alternates between positive and negative directions, flowing back and forth. In a DC circuit, the current flows continuously in only one direction, from the positive terminal to the negative terminal through the external circuit. Fifth one, voltage polarity. The polarity of AC voltage changes periodically with time, alternating between positive and negative values. The polarity of DC voltage remains fixed, with one terminal always positive and the other always negative. Sixth one is sources of supply. Common sources of AC includes electrical generators, power stations and household wall sockets. Whereas common sources of DC includes batteries, solar cells, fuel cells and regulated DC power supplies. Seventh one, applications. AC is mainly used in homes, industries, commercial buildings, electrical appliances and power transmission systems. Whereas DC is used in electronic devices, computers, mobile phones, automobiles, battery operated equipment and electric vehicles. Next, power transmission. AC is preferred for long distance transmission because its voltage can be easily stepped up or stepped down using transformers. High voltage transmission reduces current and minimizes power loss. Whereas DC is generally less suitable for conventional long distance distribution because changing voltage levels requires more complex power electronic converters. Therefore, DC is mainly used in local and battery powered systems. Next one is energy loss. In AC transmission systems, energy loss is comparatively lower because electricity can be transmitted at very high voltages, reducing current and resistive losses. In ordinary DC distribution systems, energy losses are generally higher due to resistive losses when transmitting at lower voltages. 10th one is main components. AC circuits commonly contains resistors, capacitors, inductors and transformers, whereas in DC circuit, which generally consists of resistors, batteries, switches, relays, motors and electronic components. Measurement units. In AC systems, voltage and current are expressed using root mean square values because their magnitudes vary continuously. In DC systems, voltage and current are measured directly since their values remain constant. Then next one is phase shift. In AC circuits, voltage and current may not reach their maximum values at the same instant because of inductive and capacitive loads. This difference is called phase shift. In an ideal DC circuit, voltage and current remain in phase, so there is no phase shift. The next property is impedance. In AC circuit, the opposition to current flow is called impedance Z, which consists of resistance and reactance, which is denoted as Z is equal to R plus Jx, in which the R denotes resistance and Jx, this imaginary part of this equation, denotes the reactance. In DC circuits, only resistance opposes current flow because there is no reactance under steady state conditions. And the last one, power formula. P is equal to Vrms, which means that root mean square value of voltage multiplied by the root mean square of current, which is multiplied by the cos phi, that is power factor of the circuit. Power factor is nothing but the phase angle difference between this voltage and current. So, whereas in DC circuit, the power is denoted by, as we already seen in the previous video, electrical power is equal to the multiplication of voltage and current. So viewers, we will see the next topic in the further videos. Thank you.